Hello my dear students, I am Rifna, your new chemistry teacher. So hope that you are staying safe at your home. Let's meet soon. So let us start our learning. Our new chapter is matter in our surrounding. Okay, you got one class in this chapter, isn't it? So I consolidate that points too. So first thing that in this chapter we are learning about matter based on its physical properties, isn't it? Yes, everything in our universe, it is made up of matter. Then these matters have small particles in it, isn't it? This is a matter, it has small particles in it. These small particles are very small. They are small beyond our imagination. We can't see that small particles. It's beyond our imagination. That's much it is small. Okay. Matter is made up of small particles and they are very small enough. Then particles of matter have space between them. If this is I took some water in a beaker. This is a matter. It has small particles in it. So there is space between particles of a matter. So when we add a solid to it, in the case of when I have to add some salt to this water. This is a water. This is the water taken in a beaker. Then I want to add some salt to it. So what happened when salt is added to this water? It gets disappear, isn't it? Yes. Where does it go? Yes. The salt particles go between the particles of this liquid. So the particles of one type of matter, which is particles of salt, can intermix between the particles of this liquid. So particles of one matter can intermix into the particles of another matter. So this intermixing of matter is called diffusion. So particles of one matter can diffuse into particles of another matter. Then particles of matter are continuously moving. The particles in the liquids are continuously moving. It also have kinetic energy. For moving we want kinetic energy. So the kinetic energy of the particles will increase by increasing temperature. When we increase temperature, its kinetic energy will increases. And so the particles of matter are continuously moving and they have kinetic energy and it increases on increasing the temperature. Then the particles of matter have force acting between them. Two particles of matter have a attractive force between them. If there is no any attractive force, then it will separate it, but it is stay as continuous. So there is if I am taking this chalk, the particles between the space between the particles of this chalk, there is a attractive force. Without the attractive force, it can stay like this. It can't stay like this. It will disperse into powders. Okay, so there is force acting between two particles of a matter. The strength of this force of attraction varies from one kind of matter to another. In this case, the attraction is it has some attraction between the particles, but it is not like that in the case of a chalk or in the case of this duster. So it varies depending on the matter. This is that you have learned in the previous class. So now we are going to discuss about states of matter. Generally, there are three states. You all know that. Which are they? Solid, liquid and gas. These are the three general states of a matter. We are going to discuss about these three states of matter. First, solid state. This is a pen, this is a duster, okay, and I am taking this chalk, then I am going to draw its outline. You just take your notebook and try to draw like this. Instead of duster, you have to take a piece of wood. Okay, I take a matchstick box. This is their shapes. Can we change their shape? Can we change its shape? No. I am compressing it on the board. Is it compressed? No. I am compressing this by applying force. Is it compressed? No. This is the speciality of the solid. Solids have a fixed volume. This has a volume. It will not change when I apply pressure on it. Okay. So solid have a definite volume and definite shape and distinct boundaries and fixed volume. It has a fixed volume and distinct boundaries. Then it has a definite shape. So solids have a tendency to maintain their shape when subjected to outside force. When we apply force on it, it try to maintain their shape. Then solid break under the force, but it is difficult to change their shape. They are so rigid. We can break it by applying force, isn't it? Okay. And also this pen, we can break it when we apply more force than what I applied on a chalk. So it can break, but we cannot change its shape. It is so rigid. Then consider the following situations. When a rubber band, when I stretched it, its shape is changed, isn't it? But before that we said that the shape of the solid cannot change. But when I stretch this band, its shape is changed. And then this is a bottle with sugar taken. The shape of the sugar is the shape of this bottle, isn't it? When we change this sugar into another bottle, this sugar's shape will be the shape of that bottle. But we have said that the shape of the solid substance never change. Then third condition is that a sponge, when we press a sponge, it will compressed. And we have already said that the solid cannot be compressed as well. Then how this is possible? So all the above are solids. These are solids. But in the case of in coming to these cases, what happened is that when we stretch the rubber band by applying a force and I released that, when I released that force, it regains its shape. Its shape not changed for permanent. It only temporarily changed the shape. So when I release the force, it comes to its normal state, normal shape. And when I apply excessive force, it will break. So in the case of sugar is not, this is the one matter, sugar, each individual sugar is a matter. It is like small square. So it is each individual sugar has its own individual sugar or salt crystals remain fixed where we take it out in our hand. When we take it in our hand or put it in a plate, we can see that it has a shape. It never changes when we apply force on it. And also everything has a definite shape and not the shape of this bottle. In the case of sponge, there are minute holes in the sponge. So when we and in these holes the air is get trapped. When we press it, the air is expelled out and we are able to compress it. That's why it is able to compress it, because there is air in it. If there is no air between the solid particles, we can't compress it. The compression is negligible. So that is, it has solid has definite shape, then distinct boundary, then it has fixed volume, and negligible compression. Compression means applying force. Compression. Then coming to liquid states. There is a activity given. Take some I am taking milk, 50 ml of milk in this jar. There is 50 ml of milk is here, it is in the jar. Then I am going to transfer this milk from this jar into another jar. This is 50 ml. Then again I transferring this milk into another jar of this is 50 ml. First I take 50 ml in a 50 ml jar, then I transfer it to another jar, then again I transfer it to another jar. Then my question is that, does the shape of the liquid remain same? Shape of the liquid remains same. In this case it is like a rectangle. Here also a lateral longitudinal rectangle. The shape of this milk is same in these three cases? No, shape changes. But my question is that, does the volume remain same? Does the volume remain same? In this case it is 50 ml. In the second case it is also 50 ml. In the third case it is also 50 ml. The volume doesn't change, but the shape changes. And also when we pour from one jar to another jar, does it flow? Yes. liquid can flow easily. So the properties of liquid are, it has definite volume. It has definite volume, but it doesn't have definite shape. It have the shape of container. When we take in any container, the liquid that contained in that container have the shape of that container. Okay, it depends upon the shape of the container. So it has fixed volume, liquids flow and change shape. So they are not rigid but can be called fluid. They are not rigid as a solid substance, but they are called fluid. They can flow, hence it is called fluid. So then coming to the diffusion, we have already talked about the diffusion, which are the particles that can be diffused in a liquid. For example, when we take diffusion, when we take some water in a beaker, when I add some salt, to it, what happens? The salt, particles of salt get diffused get intermixed with the particles of water. So a solid can diffuse into a liquid. Then liquid and liquid. I took some water, then I added some milk to it. What happens? The particles of milk mixed with the particles of water, they are intermixed. So liquid can diffuse into another liquid. So in other cases, when we take some water in a beaker and add in some ink to it, what happens? The ink spread everywhere. What happening is that the particles of ink get diffused in between the particles of water. So liquid can diffuse into another liquid. Then next, I am again taking some water. A gas can be diffused into a liquid. For example, you all know that the oxygen, the aquatic organism, the organism that live under the water get oxygen from where they get oxygen? Yes, they get oxygen from the water. So the oxygen and the gases in the surrounding get dissolved into water. The oxygen, carbon dioxide, etc. are get dissolved into water. Hence they get oxygen from the water. So gases can also diffused into liquid. So solid, liquid and gases can diffuse into liquids. So due to the fact that in liquid state particles move freely. In the liquid state particles move freely. Also the space between the particles are more than solid. In solid substance the particles are closer. So the space between the particles are less. But in the case of a liquid, the particles are there is a space between particles. The distance between particles are more than that of the solids. Then this is all about liquid state, that is it has definite volume, it not have a fixed shape, it changes shape. Shape changes. Then what we have said, it can flow. Okay, hence it is called a fluid. Then we can say that fixed volume. This fixed volume will never change. Then we are going to gaseous state. Coming to gaseous state, did you see that the balloon filling from a cylinder? Yes, there are a lot of balloons can be filled from a single small cylinder. How this happen? This happens because the space between the gas molecules are much more than the what? Much more than the liquid and solid state. So the gas can fill number of balloons. There is an activity given in your textbook. Take 100 ml of syringe and close their nozzle by rubber corks as shown. Take three syringes. Syringes are taken and one is with some crystals of chalk. Chalk is some crystals. Chalk is taken. Another with water. Another with gas, air. So now try to compress the content by pushing the piston by each syringe. That is, try to compress the syringe by the piston. This is a piston. Try to compress the piston to below. What happens? Then question is that what do you observe? In which case was the piston easily pushed in? And what do you infer from your observation? Which one will be come out first? Yes, the air will come out first because we can compress the air more than that of liquid and solid. Second, there will come water. Then third, there will come chalk. So air will come first because gas is highly compressible as compared to solids and liquid. For example, the LPG, liquefied petroleum gas, that we are using to cook our food. Did you see that? LPG, liquefied petroleum gas. What happening in that is liquefied petroleum gas is liquefied. It is a gas. Okay, this gas is liquefied, changes to liquid by applying pressure on it. So when we buy a gas cylinder, there will be some liquid. That liquids are gases which is compressed into liquids. And also there is CNG, it is using as a fuel in automobiles. Then also oxygen, compressed oxygen cylinders. There are compressed oxygen cylinders in hospitals for artificial respiration. So these are the examples for the compressibility of gases. Then volume of the gas. We can change the volume of when we compress I take some gases in this box and I transfer this gas into this box by compression. What happened? Its shape changes. So like liquids, gas shape also changes, but it has a fixed volume. Fixed mass. Then compressed into small, it transport easily. So the particles they come to the know what is being cooked in the kitchen without even entering there. When our mother is cooking in the kitchen, we get the smell from the kitchen. How does that smell come here? What happens? This is an instant stick. What happens when we lit it? Yes, the smell will spread everywhere. Its smell will spread everywhere. How does this happen? Yes, the particles of air. Yes, the smell of this incense stick reach everywhere in the room fastly. Isn't it like the smell coming from the kitchen? The smell of the food item that preparing from in the kitchen reaches in our nostrils at a faster rate. Even we are not entering into the kitchen. This incense stick smell also reach everywhere in the room at a faster rate, because it is the gases are randomly moving. Okay, the gases are randomly moving. This the particles of the aroma of this incense stick get diffused in the air molecules, and it reaches everywhere, and it is in a random at a high speed. So these are the characteristics of gases. And also when we take some gases in a container, I already said that it move randomly. When it move randomly, it will hit the particles will hit together and hit to the container. And when it hit to the container, there it applies a force. So this force, the applying force by this particle on the container at a unit area is known as pressure. What is the pressure exerted by these particles in a unit area is called pressure of that gas. So this is all about gases. Gases changes its shape changes. Then it has the volume of the container. Volume also changes. High compressibility. It can compress highly. So these are all about three states: solid, liquid, gas. And there is a picture given in your textbook. That's the picture of solid. The solid particles are closer and the liquid particles are some far away, and the gas molecules are more far away. The space between the particles are large for gas, and then for liquid, then it is very little for solid. So hope you understood. If you have any doubt, you can ask me through WhatsApp. So let's meet again. Thank you.